I'm a lecturer in Imperial College London, and I'm particularly focused on preterm birth and what the causes are of preterm birth. My lab is all about focusing on trying to measure lots of different chemicals in pregnant women's blood and body fluids like urine samples, and trying to see if there's anything in there that gives us an idea of what the outcome of that pregnancy is going to be. One of the things we've focused a lot on is the role of inflammation and infection in causing preterm birth. Globally, preterm birth happens in around 10% of all pregnancies. When you equate that to how many of babies end up dying because of preterm birth, it's about 1 million every year around the world. In the UK alone, there's about 80,000 preterm births a year. And those babies who can survive, unfortunately, have a lot of problems after their birth. It's the main cause of cerebral palsy, and there's a lot of long-term issues with learning difficulties and respiratory function and things like that as well. One of the problems at the moment we have is if a woman comes in, we suspect that there could be an infection, and unfortunately, often many times the infection is not obvious. It's what we call a subclinical. So if we are able to try to work out what the bacteria is and whether or not there is an infection there to start with, that's the first step. What we need to do to identify what the bacteria is to start with is use typical kind of microbiology techniques, which takes days and days and days. That's too long in the time frame of a woman who's coming in preterm labour. We need to be able to say to her in minutes what the cause is and whether or not she has an infection, what the bacteria is. So in the last year or so, my group has been trying to identify what the bacteria is using new techniques called next generation sequencing technology, but even that takes weeks. So we can now really get down to the fine details of which bacteria are present, how they are turning on and causing the preterm birth, but we need to do that in minutes, not days or weeks. So the technology that we've been developing with Professor Zoltan Takats, his machine enables us to get a sample and in a matter of minutes be able to characterize what bacteria are present. We can then feed that information straight back to the clinician, and they're able to then select out a particular antibiotic or another effective treatment that will be specifically targeted to that woman's case. So you might not realize this, but actually you're full of bacteria. You're just actually a walking carrier for bacteria. In fact, about 90% of all the cells in your body are actually bacterial cells. Now we're learning more and more about these bacterial cells in the last few years, and we know that they play a really important role in a woman's health throughout pregnancy. They play a role probably at the beginning of conception, and they also play a really important role of determining how that the fetus is receiving energy from the mother, and then at the delivery and at the time of delivery, if that baby is exposed to bad bacteria, there's often a poor outcome associated with that. So our idea is to be able to understand what are the good bacteria that we need to encourage to be present in the maternal side or in the pregnant woman throughout all of her pregnancy, and that way we can perhaps not only intervene if bad bacteria arrive, but we can also encourage, using certain methods, good bacteria to be there and help promote healthier outcomes for the babies. In the first phase of the project, what we're trying to do is to show that we can take these swab samples and immediately say within minutes what bacteria are there. Once we can do that, any further samples that we analyse, we're able to immediately say to the clinician, this is the bacteria that is present, this is a bad bacteria that's associated with bad outcomes for the mother and the baby. That clinician will then, at that point in time, give a correct and efficient and effective treatment that's likely to improve the outcome. So even in this first trial period, it looks like we should be able to have a really important and beneficial impact on both the mother and the baby.